Welcome to the second video of section 6.1, where we will be discussing the standard normal distribution. Keep in mind, from chapter 2, we discussed z-scores, and a z-score measures how many standard deviations a value x is away from its mean. When we are discussing a normal distribution, we often use this notation here, where we will put our population mean first and our population standard deviation second. And then we can transform our standard normal distribution z with a mean of 0 and a standard deviation of 1, which would look like this. You might remember from chapter 2, when we're looking for a z-score, we use the data point minus the mean divided by our standard deviation. And the z-score, once again, tells you how many standard deviations the value x is to the right or to the left of the mean. Values of x that are larger than the mean have positive z-scores, whereas values of x that are smaller than the mean, in other words, they're negative z-scores. If x equals the mean, then x has a z-score of 0. This will make a little bit more sense as we do some examples. But lastly, to find the value of x from its z-score, we can use this formula right here. Let's take a look at example 1. Suppose we have a normal distribution with a mean of 12 and a standard deviation of 3. In part B, we are asked to find the z-score of x equals 3 and explain what it represents. So let's go ahead and do this. Let's remember our formula, which is this. And then if we go ahead and plug in our values for the data point, for the mean, and for the standard deviation, we'll get an answer of -3. So this means the value of x, which equals 3, lies 3 standard deviations to the left of the mean. And next, we're asked what value of x has a z-score of 1.5. So let's go ahead and use this formula here to find x. And plug in our mean, our z, and our standard deviation, and get an x value of 16.5. And that's the end of our second video for section 6.1. I hope you found that helpful.